Hi! So today, we're gonna talk about something interesting. We're gonna talk about a book called The Nature's Numbers, specifically Chapter 1, The Natural Order, but first, let's talk about the author. Ian Stewart writes in a very marvelously clear style, but more importantly, he is very interesting. He sees the world in an interesting mathematical way. He wants us to help see the world as a mathematician sees it, full of clues and information which can lead us to deeper and deeper appreciation of the patterns and harmonies all around us. Now let's proceed to Chapter 1, The Natural Order. Stewart begins the book by describing just some of nature's multitude of patterns like the regular movements of the stars in the night sky, the six-fold symmetry of snowflakes, the stripes of tigers and zebras, the recurring patterns of sand dunes, rainbows, the spiral of a snail shell, the regular patterns or rhythms made by animals scuttling, walking, flying, and swimming, and why nearly all flowers are arranged in one of the following numbers 5, 8, 13, 21, and so on. So basically, in this chapter, the author explains the amazing facts of patterns that are found in our nature. Interesting, right?
What is patterns and numbers in nature and the world? These patterns recur in different contexts and can sometimes be modeled mathematically. Mathematics is the science of patterns, and nature exploits just about every pattern that there is, said by Ian Stewart. Objects are said to be symmetrical if their pre-image and image have the same size and shape, but are either mirror images of each other or one has been rotated to go in a different direction from the first. Patterns can be out everywhere, including animals, plants, and even our solar system.
Patterns in nature are visible regularities of form found in natural world. Natural patterns include symmetries, trees, spirals, meanders, waves, foams, tessellation, cracks, and stripes. Early Greek philosophers studied pattern with Plato, Pythagoras, and Empedocles, attempting to explain order in nature. The modern understanding of visible patterns developed gradually over the time. Mathematics seeks to discover and explain abstract patterns or regularities of all kinds. Visual patterns in nature find explanation in chaos theory, fractals, logarithmic spirals, and other mathematical patterns. Symmetries is one of the natural patterns in living things. Animals mainly have bilateral or mirror symmetry, as do the leaves of plants and some flowers such as orchids. Plants have radial symmetry, as do many flowers and some groups of animals. Five-fold symmetry is found in the group that include starfish, sea urchins, and sea lilies. Among non-living things, snowflakes have striking six-fold symmetry. Each flake structured forms a record of the varying condition during its crystallization. But true crystal cannot have five-fold symmetry unlike quasi-crystal. Rotational symmetry is found at different scale among living things, including the crowd-shaped splash pattern formed when a drop falls into a pond, and both spheroidal shape of rings of a planet like Saturn.
Mathematical shapes can always be reduced to numbers, which is how computers handle graphics. Each tiny dot in the picture is stored and manipulated as a pair of numbers. How far the dot is along the screen from right to left, and how far up it is from the bottom. These two numbers are called coordinates of the dot. A general shape is a collection of dots and can be represented as a list of pairs of numbers. However, it is often better to think of shapes as shape because that makes use of our powerful and initiative visual capabilities, whereas complicated lists of numbers are best reserved for our weaker and more laborious symbolic abilities. Until recently, the main shapes that appealed to mathematicians were very simple ones: triangles, squares, pentagons, hexagons, circles, ellipses, cubes, spirals, spheres, cones, and so on. All of these shapes can be found in the nature, although some are far more common and or more evident than others.
So, let's talk about the Fibonacci sequence and golden ratio. Mathematicians, scientists, and naturalists have known about the golden ratio for centuries. It is derived from the Fibonacci sequence, named after its Italian founder, Leonardo Fibonacci. So, in the Fibonacci sequence, each number is simply sum of the two preceding numbers. But, how do we find the golden ratio? Simple as that. Just divide the two preceding numbers. The golden ratio describes predictable patterns on everything from atoms to huge stars in the sky. Therefore, nature uses this ratio to maintain balance and the financial market. That is why Fibonacci sequence can be applied to finance by using forming techniques, retracements, arcs, fans, and time zones.
According to Ian Stewart, mathematics is brilliant at helping us to solve patterns. It is a more or less systematic way of digging out the rules and structures that lie behind some observed patterns or regularity, and then using those rules and structures to explain what's going on. It appears to us that the universe is structured in a deeply mathematical way. Mathematics is all around us. As we discover more and more about our environment and our surroundings, we see that nature can be described mathematically. The beauty of a flower, the majesty of a tree, even the rocks upon which we walk, from a zebra stripe to a spider's web, from sand dunes to snowflakes. Nature is full of patterns underlaid by mathematical principles. Whether we like it or not, mathematics will always be a part of our daily life.